Welcome grade 11s. Welcome to Tutorbox live in conjunction with COVID-19 catch-up courses. Hello. Okay, so guys, if your name starts with an A, hello. The B, hello. It's a C, hello. And obviously if it's an L, hello. Okay, all the way to Z. Hi guys. So welcome back. So today we're going to finish up exponents and surds, and then we'll also look at equations and inequalities. So guys, let's not waste time. Let's just start. Okay. Don't forget your pen and paper. You cannot watch this video without a pen and paper. Get that pen and paper, girl, boy. Okay, let's do it.
Right, so welcome back grade 11. So today we're going to finish up on exponents and surds part 2, and then we'll also touch on equations and inequalities part 1. Okay, so let's first look at simplest surd form, right? So it says we can sometimes simplify surds by writing the radicand as a product of factors that can be further simplified using this law here. Okay guys, so you already learned this in the previous video. If you missed it, please just go back and watch the video for grade 11 session 1. All right, so let's quickly look at this example. So it says write the following in simplest surd form. So we have the square root of 50, right? So that means your answer should be in surd form. Okay, so step 1, you write the radicand as a product of prime factors. Okay, so guys, if you've forgotten this, you can just recap here. Let me just explain this part to you. Okay, how to get or how to work out prime factorization. Okay, so for example, with 48, right? So 48, if I take two factors of 48, let's say in this case I took 8 and 6, you can take 12 and 4, right? You get the same answer. So let's say I take the 8 and 6. Okay, so what I'm going to do, I'm going to continue and factor 8 into 4 and 2, and also factor 6 into 2 and 3. Okay, so now I notice that for 6, I now have the prime factors 2 and 3. Okay, so I end there. But then, however, for 8, I have 4 and 2, right? But 4 is not a prime factor. 2, however, is a prime factor, right? So then I go on and I factor again the 4 into 2 2's, right? 2 times 2, I'll get 4. So therefore, 48 written as its prime factors, or 48 written in terms of its prime factors, would be 2 times 2 times 2 times 2 times 3, right? So this is the same thing as saying 2 times 4, because there are 4 2's times 3, right? There we go. Or you don't have to do that long method, because now you're in grade 11, guys. You should be able to do these. Okay, or all you can do is you use your calculator, you put the number, in this case 50, right? And then you press equal. So that number should display on your screen. The 50 should be on your screen. And then press shift, okay? And then press fact. Okay, so fact, you should see it. It's got like some comma symbols on top of the button and so on. Okay. So then the calculator will just give you that number in terms of its prime factors. Okay, so then step 2, now you go on to simplify, because now you have the square root of 5 squared times 2. So you go on to simplify that, right? So this will be equal to, because we are multiplying, so that means you can just break it apart and be like square root 5 squared times square root of 2, and square root 5 squared is equal to 5. Guys, remember, because here you're squaring, and then this is a square root, so they'll cancel each other out, and you get 5 times square root of 2, and your answer is 5 square root of 2, right? This is quite easy, guys. And then example 2, so it says write in simplest surd form with square root 75 times the cube root of 48 raised to the power of minus 1. Okay, so step 1, we factorize the radicands where possible, right? So we have square root 75 times the cube root of 48 raised to the power of minus 1. Square root 75, I can rewrite this as 25 times 3. And then I have times, right, the cube root of, because this is 48 raised to the power of minus 1. So remember, when you have a negative exponent, guys, what you have to do to simplify is you take that base or that number, right, or variable. They can give you x, they can give you a, or they can give you a number, right? So you take that number, you invert it, which is, it becomes 1 over 48, and then this minus 1 becomes a positive 1 there. Okay, So now you have square root of 25 times 3 times 1 over the cube root of 8 times 6, right? And then step 2, we use this law that we learned, okay? So with square root 25 times 3, you can break it down to square root 25 times square root 3 times 1 over cube root of 8 times cube root of 6, okay? Square root 25, we know it's 5, and square root of 3 is square root of 3, because if you change it, you get a decimal, but then we want it in surd form, so we leave it like that. And then times 1 over cube root of 8 is 2 times the cube root of 6, you also get a decimal, so just leave it like that, okay? And then you simplify, you should guess your answer to be 5 square root 3 divided by 2 cube root 6. Okay, so guys, if you know, you didn't actually have to like go through this whole step, right? So you can just put 75 and get the prime factors for 75, or you just use your calculator and then it should finally give you something like this here, and then you can simplify it, okay? Right, and then next up we have rationalizing denominators. So it is often easier to work with fractions that have rational denominators instead of surd denominators. Okay, so they're saying it's easier for you to not work with something like this because that's just nasty. So by rationalizing the denominator, we convert a fraction with a surd in the denominator to a fraction that has a rational denominator, right? So we want to change this fraction so that at the bottom here, we have a rational denominator, okay? So what do we do? So the question says rationalize the denominator. So we have 5x minus 16 divided by the square root of x, okay? So first step, you multiply the fraction, this fraction, by square root x divided by square root x, okay? So notice that if I multiply by square root x times square root x, I get 1. So the value of the fraction has not changed. Okay, so guys, whenever you're rationalizing, make sure that you are actually multiplying by 1 here, okay? Because you don't want your fraction to change at all. You want it to stay the same, okay? But then you can manipulate the 1 so that it looks something like this, because if you take square root of x divided by square root of x, you get 1, okay? So now we have 5x minus 16 over square root of x times, I multiplied by my 1 here, but I can rewrite my 1 as square root x divided by square root x, because remember, I want to remove that square root sign, okay, because I want a rational denominator, okay? So then if I multiply this, at the top I have square root x times 5x minus 16, and then here I have square root x times square root x. Okay, so let's see what happens next. So we're here, guys. So step 2, we simplify the denominator. So now we have square root x times 5x minus 16 divided by square root x, everything squared, okay? And then the top stays like that, but the bottom, however, because you have square root x times square root x, okay? So you have a square root sign here, and then this is actually squaring, so that will disappear. You're left with your x. Or you can think of it as square root x, remember, is x raised to the power of half. So you can just say x to the power of half times x to the power of half, and then you have the same base, so you're going to add your exponents. So half plus half will equal to 1. So that's why we have x raised to the power of 1 there. Okay, so whichever way is easier for you. So the term in the denominator has changed from a surd to a rational number. Expressing the surd in the numerator is the preferred way of writing expressions. Okay. Now let's look at another example that has 2 terms at the bottom. So this one had 1 term. See, it had 1 term, and then now it's got 2 terms. So it says rationalize the denominator. Okay, so guys, for the ones that have 2 terms, this is what you do. So step 1, you find the conjugate of the denominator. So in general, the conjugate of a plus b is a minus b, and vice versa. Okay, so for conjugate, all you're doing is you take that first term, you take the second term, and what you do is you change the sign in the middle. So if it was a plus, it becomes a minus. Okay, so what would the conjugate of our denominator be? So in this case, we have x plus square root of 3. So we take this first term stays the same, the second term stays the same. The plus, however, has to change. So our conjugate for this question would be x minus root 3. Okay, and then step 2, we multiply the numerator and the denominator of the fraction by the conjugate found in step 1. Okay, because remember here we're multiplying by 1. This divided by this is actually 1. Okay, so we have 4 over x plus root 3. You're going to multiply by x minus square root of 3 divided by x minus square root of 3, and then you get your answer to be 4x minus square root of 3 over x squared minus 3. Okay, so guys, these are very, very easy marks that you should actually get in all the tests and exams that you write. These are very, very easy marks. You guys shouldn't like be losing marks here. All right. Alright guys, so next up we have solving surd equations. So we also need to be able to solve equations that involve surds. Okay, so let's just look at this example here. So we have solve for x, and our equation is 5 times the cube root of x raised to the power 4 is equal to 405. Okay, so step 1, write in exponential notation to make life easier. Okay, so we have 5 times x raised to the power 4, and all this raised to the power of a third is equal to 405. Okay, so remember guys, we are changing from this to this because of that law that we learned, the one that says that the nth root of a is equal to a raised to the power of 1 over n, right? So in this case, our a is x raised to the power 4, there is x raised to the power 4, and our n is 3, so it'll be 1 over n, which is 1 over 3. Okay, so this is equal to 405, right? So if I simplify this, I'll get 5 times x raised to the power of 4 over 3 is equal to 405, because this 4 will multiply that 1 over 3. Okay, so this is also another law, but then this is a law that you learned in grade 9, 10. Okay, so you should know it by now, right? And then step 2, we divide both sides of the equation by 5 and simplify. So we have 5x raised to the power of 4 over 3 is equal to 405. We divide by 5, divide by 5. We get x raised to the power of 4 over 3 is equal to 81, right? And then we want to change 81, right? So that we put it in terms of its prime factors. So this will be x raised to the power of 4 over 3 is equal to 3 raised to the power of 4. Okay, so guys, before we go to step 3, let me just explain this part. Okay, so remember, when we have for example here, we have the cube root of y is equal to 2, right? So I just put a 1 there so that you guys follow through nicely. So the cube root of y is equal to 2, right? So this I can rewrite in exponential notation as y raised to the power of 1 over 3 is equal to 2. So this y raised to the power of 1 over 3 is the same as this cube root of y, right? And then now, because I want to solve for y, right? So if I cube this whole thing here, right, I'll also cube this part, that 2 there. What I do this side, I do this side, right? So if I take this expression cube root of y and then I cube it, this will be equal to 2 cubed. Okay, so you should notice that this is actually the same as saying I take that y raised to the power of a third and I cube it. Okay, then I'll get 2 cubed as well. Okay, because remember, this is just another way of writing that guy there. All right, so because now I have cubed it, and then here I have the cube root, so those will cancel out, and then I get my y will be equal to 8. It's the same thing this side. I have y raised to the power of a third, right? And all this is being powered to 3, right? So this will be equal to y raised to the power of 3 over 3, because I just multiply here the exponents. Okay, so that will be 3 divided by 3, which is 1, so y is equal to 8. All right, so guys, just notice that whenever you're given maybe something like this, right, whenever you're given something like this, and you come to this step here, right, and then you rewrote it like here, the inverse of 1 over 3, but a positive one, it doesn't change the sign. So if you have 1 over 3 here, outside your power would be 3. Okay, so you just notice with this example here. Okay, so step 3, we have simplify the exponents. So let's just recap on this part. So we have x raised to the power 4 over 3 is equal to 3 raised to the power 4. All right, so we want to solve for x. Okay, so remember, we have x raised to the power 4 over 3 is equal to 3 raised to the power of 4. All right, so what you do is, because this is not that question where you have like the same base and then you're trying to find the exponents. Now the x is actually the base and we're trying to get what that x is. Okay, right. So what you do is you have x raised to the power 4 over 3 is equal to 3 raised to the power 4. Right. So now, because you want to be left with the x, right? So what you do outside is you're going to power this whole expression by 3 over 4. And what you do this side, you do this side, you're also going to power it by 3 over 4. Remember what I explained here. This is the same as that there. Right. So therefore, x is equal to 3 cubed. Because here, if you multiply, you have 4 times 3 is 12. 3 times 4 is 12. That'll be 1. And then we have, if you divide, and then here you have 4 times 3 is 12. Divided by 1 times 4, you get your 3. Right. So therefore, x is equal to 27. And therefore, don't forget to check the solution by substituting the answer back into the original equation. All right, guys. So this is an NB trick to solving ones where, because you guys are used to the ones where the x that you're solving is the exponent or the power. Now the x is the base. Okay, so if it's the base, this is the trick that you use. Okay, I'll do another question where the x is the exponent and then you see the difference. Okay, just make sure that you have an NB here. Right. All right, and then let's look at the second example. So we have solved for z, and we're given the equation z minus 4 raised to the power, z minus 4 square root of z plus 3 is equal to 0. I'm already skipping it to this part. Okay, so the solution, right? So when you notice something like this, right, just remember your quadratic equations. So you have something equal to 0, but that's not enough to say it's a quadratic equation. But then you have a constant, okay? You have a z here and you have a z here, because remember quadratic equation, you have ax squared plus bx plus c. So you have a c, which is a constant, it's equal to 0, okay? And then you have your x squared. This can be some x squared or something like that. And then you also have your bx. There's my b is minus 4, and then I have an x there, but I still have to manipulate it. Okay, so when you notice something like the question like this, just think of quadratic equation, manipulate it so that it's a quadratic equation. All right, so let's look at what we do. So we have z minus 4. Obviously, let's change that third form. So there will be z minus 4 times z raised to the power of half plus 3 is equal to 0, right? And then we let k be equal to z raised to the power of half, right? So you always let k equal to this. If it's not clear that it's a quadratic, right, just let your k be equal to your variable for the second term. Okay, so let k be equal to z raised to the power of half. So k squared, if you square this guy here, you're going to get z raised to the power of 2 over 2 is equal to z. Oh, so it means k is this and k squared is that. So therefore, we have a quadratic equation. Okay, so now you substitute. You have k squared minus 4k plus 3 is equal to 0. And then k squared minus 4k plus 3 is equal to 0. I just rewrote that there, right? And then solving quadratic equations, guys, you should know this by now. So you want to look for factors of 3 that when you multiply, they give you 3. And when you add, they give you minus 4. So our answer is minus 3 and minus 1. Okay, so if k minus 3, k minus 1 is equal to 0. So therefore, k minus 3 is equal to 0. So k is 3. Or k minus 1 is equal to 0. So k is 1. Right. So now remember, I just did a sum and product here, in case some of you have forgotten. So now remember, k is equal to z raised to the power of half. So you can't leave it here, guys, because they asked you to solve for z, not for k. So you can't leave it here. So now remember, k is equal to z raised to the power of half. So now you take your k, which is z raised to the power of half, is equal to 3, or your z raised to the power of half is equal to 1. And then you solve the equation. So here you actually didn't have to do this second step. You can change it to surds. If it's easier for you to work with surds, go ahead. If it's easier for you to work with exponents, then go ahead. Okay, so here you have z raised to the power of half is equal to 3. And then I change this so that I have like a square root of z is equal to 3. And then I'm going to square both sides because I want to get rid of the square root. So I'm now left with z is equal to 9. And then I do the same thing here. I get z is equal to 1. Okay, guys. So now it's time for you guys to try this one out. So this is actually similar to something like that. I want you guys to notice and be able to pick up that, oh, okay, it sort of looks like a quadratic equation, but a hidden one. Okay, so I'll give you guys 30 seconds to just scribble down what you think you do and scribble down what you think k should be, and yeah, and then we'll take it from there. Okay, so let's look at the solution. So we have, I hope you guys have something like similar to this. I know you didn't like get to finish the whole thing, but your ideas should have been something like this. Okay, so first, obviously, we need to expand and simplify this guy. So we have x, this will become x raised to the power of 2 over 3 plus x raised to the power of third is equal to 6. And then this will be x raised to the power of 2 over 3 plus x raised to the power of third minus 6 is equal to 0. Okay, so now that looks like some quadratic, but it's hidden. We don't know it, but it's a quadratic, but it's hidden, right? So we let k be equal to x to the power of 1 over 3. Okay, there we go. There, because my b now, my coefficient there is 1. Okay, so you just take this one. So guys, notice that you never, for the part where you say let k equal to something, don't take the constant or the coefficient. Just take the variable part in its power. So let k be equal to x raised to the power of a third. So k squared will be equal to x raised to the power of third squared. This will be equal to x raised to the power of 2 over 3. Right, then now you substitute. Right, you have your k squared is this, so you just substitute. So you have k squared plus k minus 6 is equal to 0. And then you look for two numbers that you multiply to get minus 6. And if you add, you get plus 1, you get minus 2, and you get plus 3. Factors, by the way, guys, factors of minus 6 or 6. So if k minus 2, k plus 3 is equal to 0. So k minus 2 is equal to 0. So k is 2, or k plus 3 is equal to 0. So k is minus 3. But remember, you cannot leave it as k is equal to 2 or k is equal to that. You need to change it because they want it in terms of x. Okay. So remember, k is equal to x raised to the power of a third. So if I have x raised to the power of a third, it's equal to 2. So you can change it to this. I prefer working it out like this. So it's up to you. You can just like cube it from here. It's fine. So you should get x is 8 or x is minus 27. So check this one out, guys. I didn't put down the working so that you guys can check it out. Okay, so guys, this is a very, very easy marks. Okay, so you should always aim to get full marks in questions like these because they are very easy. As long as you master the tricks, just need to master the tricks. That's all that's important. Okay, and you always need to practice, practice, practice. We need to practice questions from past exam papers. Okay, so the ones that are ticked in green, these ones, you guys, you can work them out by yourselves. I want us to do 2.22 together and 2.23 together. Okay, so that's 2.22 and 2.23. Okay, so let's see what we do. So 2.22 says 4 raised to the power of x plus 8 is equal to 9 times 2 raised to the power of x. Woo! Okay, so what do we do? So first, just notice something here, okay? it might look like a quadratic, but we're not sure because now the x is at the top, it's not at the bottom. Like, what's happening? Okay, but don't freak out. Okay, you just need to know the tricks. That's all you need to know. Okay, so first thing, just rewrite this, bring everything to one side, and then you equate it to 0. Okay, and then what I did next was, because I have 2 raised to the power of x, right? When you bring it to this side, you see that you have a constant, you have equal to 0, and then you have your minus 9 times 2x. So that means this part here should represent the bx in the quadratic equation. Okay, so basically you know that your k will be 2 raised to the power of x. So now you can manipulate this guy here, the 4 raised to the power of x, to sort of have something like this, so that you can square it. Okay, so let's see what I did there. So with 4, I rewrote 4. I can write 4 as 2 squared, right? And then all that raised to the power of x. And then if I simplify it, I get 2 raised to the power of 2x minus 9 times 2 raised to the power of x plus 8 is equal to 0. Okay, so now it looks like a quadratic, okay? We have that there, we have something like that. It's hidden, but it's there, right? So let k be equal to 2 raised to the power of x. Okay, and then we substitute, right? So this now, because we have 2 raised to the power of x and we have a 2 there, so this becomes k squared, right? K squared, because there's that 2 there. K squared minus 9k plus 8 is equal to 0. And then I factorize. Okay, I look for factors of 8. That would give me, if I multiply, I get positive 8, and if I add, I get minus 9. So I get k minus 8 and k minus 1 is equal to 0. Right, so therefore k minus 8 is 0, so therefore k is 8, or k minus 1 is 0, so therefore k is 1. Okay, so guys, remember, you cannot leave it as k, because they ask you to solve for x. Okay, so now this is the example that I was talking about, the one that has the solution being in the same basis, and then you get your x. Whereas that one had the x being the base, and then you were given exponents. Okay, so you guys need to, if you can, please just write down the tricks to those, or you can just put 2 of those examples side by side so that you can analyze them when you're studying and stuff. Okay, so if k is equal to 8, so if 2 raised to the power of x is 8, 2 raised to the power of x is equal to, we change 8. This would be 2 to the power of 3. Okay, so with the same base, therefore x is 3. And then this side, we have 2 raised to the power of x is 2 raised to the power of 0, and x is therefore 0. Okay, and then let's look at 2.23. 2.23 says you want the x root. Yeah. So you want the x root of 9, okay, is equal to 243. So you want to solve for x. Okay, so you do the same thing. Imagine maybe here you had a squared, a 2, you had a 2 here, right? So that would be the square root. Okay, so what you do with the square root, obviously you're going to do with the x root, right? So that here they're just trying to make life hard, but it's actually not that hard. Okay, so what you do is you would power this to the power of x. You also do the same thing here. You power it to the power of x. So now this x the root and the x power will cancel out. You're left with the 9. And then this side you have 243 raised to the power of x. Okay, and then let's change them so that we have the same base, because you see the thing that you want to solve for, the x is at the top. So basically your trick is to change the bases so that they're the same. All right. Okay, so we have 9. That would be 3 squared is equal to 3 raised to the power of 5x. And then I have the same base. So therefore 2 is equal to 5x. And then if I divide by 5, I get x is 2 over 5.
All I do is talk no matter what. Got systems on my mind, I can never get enough. And every time I step up in the classroom, all my students' hands go up. And they stay there, and they stay out, and they stay there. Up, down, up, down, up, down. That's all I do is solve. And if you're solving it, put your hands in the air, make them stay there.
It's Schultz going in the verse, 'cause I'm solving this system and I won't stop now. Keep your heads up, eyes on the screen, 'cause I got 3 ways to get the conflict down. It never went nowhere. You can say in math is fact. Sometimes equations are easy. That's when I like to graph. And I'm on the system's track, so I spit my graphing flow. The lines slant up or down, like lines where slope should go.
All right, guys, so that's the end of this what's it called? Exponents and surds, right? And then now we have equations and inequalities. So this is chapter 2, right? So revision, so solving quadratic equations using factorization. Guys, this is like recap from grade 9 and 10, right? So expression, you should know what an expression is. Equation, you should know what an equation is. Inequality, you're using this signs here. And then a solution, a value, a set of values that satisfy the original problem statement. So a solution will basically maybe be your x is equal to 5 or whatever. And then your root, a root, this is important because we're going to cover this part. So a root of an equation is the value of x such that f of x equal to 0. So what this means, f of x, it means if you take the x value that you got, okay, and then you plug it into the function, the f, right, you should get 0. Okay, that's what a root means. Okay, and then a quadratic equation is an equation of the second degree. The exponent of one variable is 2. Okay, so the following are examples of quadratic equations. We have 2x squared minus 5x is equal to 12. You see that we have a second degree there. X is raised to the power of 2. Okay, so you can write this as 2x squared minus 5x minus 12 is equal to 0. Okay, same thing here. If you simplify, you should get a quadratic. And then same thing here. If you solve, you should get a quadratic. Remember to solve these ones, guys, you need to get the LCD. All right, remember fractions, grade 6. Right, and then a quadratic equation has at most 2 solutions. What this means, at most, guys, it means it's that thing and then below. Okay, so a quadratic equation has at most two solutions. That means go 2, it can have 1, or it can have 0. All right, that's what it means. Right, so these solutions are also referred to as roots. There are some situations, however, in which a quadratic equation has either one solution or no solutions. All right, and then I just put this so you guys can sort of visualize what I mean by at most 2 solutions. Okay, so let's start with this guy here. Okay, so with x squared, y is equal to x squared minus 4. You see that the graph here is cutting the x. This is our x-axis, that's our y-axis. It's cutting here at minus 2 and here at 2, and then the y-intercept is minus 4. All right, so that means that the roots are at minus 2 and at 2. So x is 2 and x is minus 2 are roots of this quadratic equation. Right, so yeah, that's about it for that one. Okay, and then the second one, we have y is equal to x squared, right? Y is equal to x squared, right? So y is equal to x squared, the graph of a quadratic equation with one root. So you see that this graph is actually touching or cutting the x-axis at only one point, the 0 there. All right, so that means we have one root. Okay, and then the third one, let's look at the one that doesn't have any real roots. So you see now this graph is not touching like the x at all. Like it's just not touching it. Okay, so if y is equal to x squared plus x plus 1, so this is a graph of a quadratic equation with no real roots. It doesn't have any real roots. Okay, right. And then we need to know how to solve equations using factorization. So okay, let's look at this example. So it says solve for m. So if m plus 2, guys, I hope you remember what factorization is. I mean, yeah. So for m, we have m plus 2 is equal to the square root of 7 plus 2m. I don't know where I got 9 from. Step 1, you square both sides of the equation. Surds, guys, solving surd equations. Okay, so you're going to square both sides of the equation. So you're going to square this side and square this side. Okay, so if you square this side, because here you have a square root and then you're squaring, that would disappear. So you have 7 plus 2m. Then this side, you have m plus 2 and then squared. So if you expand this, you should get m squared plus 4m plus 4 is equal to 7 plus 2m, right? And then bring everything to this side. You have m squared plus 2m minus 3 is equal to 0. And then factorize. That's what they mean by solving equations using factorization. Factorize, right, this part. You look for the factors of 3. That when you multiply, you get minus 3. And then when you add, you get plus 2, right? So that'll be minus 1 and plus 3. So your answer, therefore, would be m minus 1 is equal to 0. or m minus 3 is equal to 0. So m is 1 or m is equal to minus 3. Right. And then, guys, you also need to know how to complete the square. Right. So completing the square is pretty easy. Right. So what you have to do when you're completing the square, or they ask you to complete the square, always make sure your equation is in terms of ax squared plus bx plus c equal to 0 first before completing the square. And your a should always be 1. Okay, so the coefficient before that x squared should always be 1. So if you see that maybe it's like 5 or 6, then divide by that coefficient throughout all the terms so that you have a 1 here. Right. So what do we do then when we're completing the square? It's very easy. So if x squared minus 6x plus 8 is equal to 0. Okay, so first let's check coefficient. Is it 1? Yes. So coefficient of x squared is equal to 1. Okay, so what you do first is take this part, the x squared minus 6x, just open your bracket, put the x squared minus 6x, leave some space here. Okay, leave some space there, and then close that bracket, and then you put your plus 8 there, the figure that they would have given you here, or the constant. So you put your plus 8 there, and then leave some other space there, and then you equate it to 0. All right, and then now you come below this second term, right? You take half of it, right? So half of minus 6, you get minus 3. Okay, and then now you take this minus 3 and you square it. The answer of it, you put it there. So this will be a plus 9 there, and then outside you come into the opposite, you subtract your 9. Right, and then now if you simplify this guy, you should get x minus 3, x minus 3. Okay, and then you have plus 8 minus 9, you get minus 1 is equal to 0. Okay, and then now this you can rewrite as x minus 3 squared minus 1 is equal to 0. Okay, so basically you're sort of working it out so that you get like a difference of squares. Okay, so now you have x minus 3 squared minus 1 is equal to 0. Right, and then you take your x minus 3 squared is equal to 1. Right, so there we go, x minus 3 squared is equal to 1. And then because here I have a squared, I'm going to take the square root. So I get x minus 3 is equal to plus or minus 1. Remember, the square root of something, you get two numbers, a plus and a minus. So this will be plus and minus 1. Okay, so therefore you have x minus 3 is 1. So x is equal to 1 plus 3 is 4. Or x minus 3 is minus 1. So x is equal to 2. All right, guys, that was very easy. Okay, and then now we want to solve quadratic equations by completing the square. Okay, so I'll just start this one off, and then you guys will notice that it's very easy. You just refer back to this part, and then you can complete it by yourselves. So question says solve by completing the square. So if 2x squared minus 6x minus 10 is equal to 0. So step 1, guys, always make sure that your coefficient here, it's a 1. But then you see now it's a 2. Right, it's a 2, so you need to get rid of that. Okay, so step 2, make sure that the coefficient of the x squared term is equal to 1. So the coefficient of the x squared term is 2 in this case, so therefore divide the entire equation by 2. So you're going to divide by 2, so that here you're left with the 1. Divide by 2, divide by 2, divide by 2, and then now you should get x squared minus 3x minus 5 is equal to 0. All right, so guys, then work it out like the previous example here. You take this part. Don't forget to put your bracket, leave your space here. This stays the same, but it's outside the bracket, and then leave your space, okay? And then you do this quick method here, and you just keep doing the math, okay? So then you can check. This is the answer that you should get. All right. Right, and then now we also need to know the quadratic formula. Guys, we need to know the quadratic formula. So it's not always possible to solve a quadratic equation by factorization, and it can take a long time to complete the square. Right, so the method of completing the square provides a way to derive a formula that can be used to solve any quadratic equation. Right, so the quadratic formula provides an easy and fast way to solve quadratic equations. So therefore, for any quadratic equation, ax squared plus bx plus c is equal to 0, we can determine the two roots. So you can get this root, the x there, minus b plus square root of b squared minus 4ac all over 2a, or x is equal to minus b minus square root of b squared minus 4ac all over 2a. Right, so it is important to notice that the expression b squared minus 4ac, this guy here, this guy, so b squared minus 4ac must be greater than or equal to 0 for the roots of the quadratic to be real. Right, this part here, it should be greater than or equal to 0. Right, if the expression under the square root sign is less than 0, then the roots are non-real, they're imaginary. Okay, so if this is maybe let's say minus 4, then the roots are non-real. Okay, so for them to be real, they have to be, this part here has to be greater than or equal to 0. Alright guys, so let's just do an example. This is fairly simple. So it says solve for x, because all you have to do is just remember the quadratic formula. Okay, so it says solve for x and leave your answer in simplest Surd form. So if 2x squared plus 3x is equal to 7. Okay, so if you bring it this side, you get 2x squared plus 3x is equal to 7. Right, so first step, check whether the expression can be factorized. No, you shouldn't be able to factorize that. Okay, so if you see that you can't factorize it, so then the general quadratic formula must be used. So step 2, you write the equation in the standard form, ax squared plus bx plus c is equal to 0. So if you bring the 7 this side, we should get 2x squared plus 3x minus 7 is equal to 0. And then step 3, you identify the coefficients to substitute into the formula. So my a there is 2, there's my a, guys, it's 2. My b is here, that's 3. My minus 7 there is my c. Right, and then now this is our formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So step 4, apply the quadratic formula. Always write the formula first and then substitute the values of a, b, and c. Okay, so whether it's b, you substitute with your b value here, which was 3. And then where there's a, you put your a, which is 2, your c, you put your minus 7. Okay, then you just like do everything in your calculator. You don't have to do it by head. Okay, unless if you're that keen on doing maths. But then you should get this answer here. Right, and then you write the final answer. So the two roots, because remember there's a plus and a minus, so the first root is the one that's going to have a plus, and then the second root will have a minus there. Now this question says find the roots of the function. So you see now it's no longer saying solve for x. So you should know that when they say solve for x, they're basically saying find the root of that equation. Right, okay, so now they're saying find the roots of the function f of x is equal to x squared minus 5x plus 8. So finding the roots, to determine the roots of f of x, you need to let this f of x be equal to 0, right? First, check whether the expression can be factorized. If you see that you can't factorize it, then you have to use the general quadratic formula. So a here is 1, right? There's a 1 there. And then b is minus 5 and c is 8. And then you just put everything in your quadratic formula and then you should get that there. Okay, so remember you have the two roots. You have the one with the plus and the one with the minus. Okay, so I wanted to show you guys like in a graph how it would look like. All right, so it says write the final answer. So there are no real roots for this. Okay, let's go back. So we have, notice here guys, we have 5 plus or minus the square root of minus 7 divided by 2. Right, so this one now has a minus 7 under the square root sign. Remember what we said on the other slides, right? We said that if we have a minus, because we always want this part under the square root, right, to be greater than or equal to 0. But then because it's less than 0, it becomes non-real, right? So it's imaginary, right? So it won't have any real roots. Okay, so there are no real roots here because of that minus 7 that's under the square root. So this means that the graph of the quadratic function has no x-intercept. So the graph does not touch the x-axis. Okay, so the entire graph lies above the x-axis. So the graph will actually lie there. The y is going to cut the y at 8. Okay, and then it's going to go like that. Right, so you guys should be able to like graph these from the previous grades. Okay, guys, and then we have substitution. Okay, substitution. It is often useful to make a substitution for a repeated expression in a quadratic equation. This makes the equation simpler and much easier to solve, right? So for example, let's say they give you something like this. You see that there's something like this here, and then that thing is also there, you know? So what you can do is you solve the equation using substitution, right? So you let this be equal to maybe m or k or whatever, right? So solution, the first step that you have to do is to determine the restrictions for x. So the restrictions are the values of x that would result in the denominator being equal to 0. But then if it's equal to 0, that would make it undefined. Right. Okay. So therefore, x cannot be 0, because if x is 0, this will be 0. It will become undefined. And x cannot be 2 either, because if this is 2, then it will be undefined. And then we can't work it out. We're stuck. Okay. So step 2, you substitute a single variable for the repeated expression. So we have a repeated expression. So just always check, do you have a repeated expression? If you see that you have a repeated expression, then simply use substitution. Substitution is your guy for this part. Okay. So you're going to let k be equal to that, so that the equation becomes k minus 3 over k is equal to 2. Okay, guys. And then now you know how to solve this. You have k minus 3 over k is equal to 2. Right, so what you're going to do is you can find the LCD, or because there's only just one denominator, just multiply throughout with that denominator. So this will be k squared minus 3 is equal to 2k. You bring the 2k this side, it becomes a quadratic equation. So therefore, you get your factors, right? That would give you, if you multiply, they'll give you minus 3. If you add, they give you minus 2. So that will be k plus 1, k minus 3 is equal to 0. So therefore, k is minus 1. Or k is equal to 3, right? So now you have to always check, guys. You always need to check, okay, so that you don't lose any marks. So we check these two roots again against the restrictions for k and confirm that both are valid, right? So we have k is minus 1. Use values obtained for k to solve for the original variable x. So we have for k is equal to minus 1. So remember, guys, you can't leave it as k because you did a substitution and they asked you to solve for x. So you always need to leave it in terms of x, right? So for k is equal to minus 1, right? You have x squared. Remember, x squared minus 2x was equal to your k. So now x squared minus 2x will be equal to minus 1. And then you do the maths. Therefore, x is 1. And you do the same thing for 3. And then you get x is minus 1 or x is 3. Okay. Then you write your final answer. You get that root, you get that root, and you get that root. Alright, guys, so that's the end of our session. Thank you for joining me, and don't forget to come to the Q&A because I'll be going over some questions from past exam papers. Alright, and for those of you who are not joining me, thank you. Bye.